In this lesson, we're going to solve linear equations with rational number coefficients. Let's take a look at some examples. 3/5 x plus 2 equals 7/3 x minus 7. Alright, so this looks a little ugly just because of all the fractions we have here. And what I want to do is clean up all these fractions. Now we have a method to make this equation solvable without any fractions. Let's take a look at our denominators for a second, okay? We have 5 as a denominator, 2 over 1, we could say 7 over 3, x minus 7 over 1. So if we just highlight our denominators for a second, we have 5, 1, 3, 1. And now what we're doing is looking for a common denominator for all four of these numbers. So 5, 1, 3, and 5. And 1, excuse me. What I like to do is I like to highlight the biggest denominator as C. Well, 5 is right now the biggest denominator. And I want to ask myself, does each one of these denominators go into 5? Can 1 go into 5? Yes. Can 3 go into 5? Well, 3 cannot go into 5, so we have a problem here. And then the last one, can 1 go into 5? So 2 out of the 3 denominators can go into 5. Okay. So because the 3 can't go into 5, I cannot use 5 as a common denominator. Let's look at the multiples of 5. 5, 10, 15, 20, 25, and so on. What I'm looking for is the first multiple of 5 that all four denominators can go into. So I'm going to ask myself, well, we just asked ourselves, can they all go into, can 1, 3, and 1 go into 5? No. Can 1, 3, and 1 go into 10? No. Meaning when I say going into, or can I say 5 divided by 3 and get a whole number? No. Can I say 10 divided by 3 and get a whole number? No. 15 divided by 3 and get a whole number? Yes. I could do 15 divided by 1 get a whole number. Get 15 divided by 3 get a whole number. 15 divided by 1 again and also get a whole number. So 15 is my common denominator that I'm going to use. So let's clean this up for a second. So now that I clean this all up, what I'm going to do is I'm going to multiply each one of these terms by the number 15, which was my common denominator. Okay, I'm going to do this one a little bit longer, and I just want to show you how. So I'm going to take 15 and multiply by each number. So I'm going to say, okay, 15 over 1 times 3 over 5x. Alright, and then I'm also going to do 15 over 1 times 2 over 1, which is my second term. I'm going to do 15 over 1 times 7 over 3x. And last but not least, I'm going to do 15 over 1 times negative 7 over 1. Alright, so I'm going to multiply each one of these terms by this 15. So I'm distributing to each one of these terms here. What should happen is my denominator should simplify and cancel. Or so it should simplify and I should be left with just an integer. So let's look at our first one. We got 15 over 1 times 3 over 5x. Now the 15 and 5 can simplify. 5 can go both into both these numbers, and I get 3 and 1. My denominators here should always be 1, okay? And that's the reason why I'm multiplying by 15. So now I have 3 times 3x, and I have 9x. So my first term turned into 9x. My second term, 15 over 1 times 2 over 1, well, nothing can simplify, the ones are just the same. So 15 times 2 is 30, so plus 30 equals my third term here. 15 over 1 times 7 over 3, well, my 15 and my 3 simplify. Both are divisible by 3. 3 divided by 3 is 1. 15 divided by 3 is 5. And then I have 5 times 7x, which is 35x. And last but not least, I have 15 over 1 times negative 7 over 1, and my 1's are, I already have 1 in my denominators, so 15 times 7, and I get negative 105. Okay, so this is a very important process here. Again, I'm multiplying by 15 to clear out all my denominators. Now I can solve this equation here and still yield the same answer, except without any fractions. So let's take a look at that. Okay, so I want to get my x's on one side and my constants on the other. So I'll do this in two different steps, and then we'll try some where we bring it over in one step. So we have this term, we have this here. I'm going to bring my 9x over to the right. It doesn't matter where you bring it. I'm just bringing my smaller one over. So minus 9x Okay, so this all should be somewhat familiar. My 9x is going to go away, simplifying, so I'm left with 30 equals, and I'm going to be left with 35x minus 9x should be 26x minus 105. Okay, now my second goal is to bring my 105 over to the other side, so that way my variables on one side, constants on the other, so plus 105, plus 105. These here should simplify. I'm going to get 135 equals 26x. Okay, so now I'm getting closer. My last step here is to divide by 26 to isolate my x. Divide this side by 26. And I'm left with x equals 135 over 26. Always try to simplify if you can. I don't believe this one can simplify. So there is your final answer. X equals 135 over 26. Let's take a look at another example here. 1/3 a plus 2 equals 1/2 a minus 7. Alright, so again I'm going to look at my denominators. I have 3, 2, and then I have these here with imaginary 1s. Okay, so my highest denominator is 3. Let's look at the multiples of 3. 3, 6, 9, 12, so on. What number can I divide into each one of these numbers? I could divide 3 into 3, 1 into 3. I can't divide 2 into 3 evenly, so that goes away. 6, can I divide 3 into 6? Yes. 1 into 6? Yes. 2 into 6? Yes. And 1 into 6. So each one of these numbers will divide into 6 evenly, so I'm going to multiply everything through by 6. So in the last example I wrote them all on the side here. What I'm going to do here is multiply every example, so every number by 6, or 6 over 1. And what I'm going to do is write this one a little separately. So rather than writing them on the side, I'm just going to multiply this by 6 over 1. I'm going to multiply this one by 6 over 1, by 6 over 1, and by 6 over 1. And I can write them here. Just try not to confuse yourself and make it too messy. Whatever method you prefer, that's fine. So again, I distributed through all of them and multiplying them all by 6 over 1. So here, my first terms, 6 and 3 simplify. This turns into 1. This turns into 2. So I'm left with 2 times 1a, or just 2a, plus the 1's don't do anything for me, so 6 times 3, 18, equals. Here my 2 simplifies with the 6, turning this into a 3. 3 times 1a is 3a. And then again, this 1's don't do anything for me, and negative 7 times 6, and I get negative 42. Alright, so now we cleaned this all up. We got rid of our fractions. Again, we're solving for our variables. I'm going to do this one in 2 steps. So I know I need to bring my a's over to one side and my constants over to the other side. So let's do that all in one step here. So I'm going to bring down my 2a over to the left side. And again, I'm just bringing the smaller one over to the bigger one. Doesn't matter, preference, whatever preference you like. And I'm going to simultaneously, so that'll get rid of that. And simultaneously, I'm going to bring my 42 over to the left side. So I'm going to add 42. That'll get rid of that. Okay, and now let's see what's left here. So I got 18 plus 42, and I should get an answer of 60 equals 3a minus a, and 60 equals a, or a equals 60. Let's take a look at another example. So this one we have one more step here, okay? So we're going to distribute here. So we have negative 1/3 times 2/3 minus 4. So negative 1/3 times the quantity 2/3 x minus 4 equals 1/2 a minus 7. So we're going to do a little distributive property here, single distribution. And let's do that first. So we're going to multiply negative 1/3 times 2/3 and negative 1/3 times negative. So I'm going to distribute before I try to clear any fractions, okay? So if you see any distributive properties, do that first. So I have negative 1/3 times 2/3. I'm going to do that here on the side. So negative 1/3 times 2/3 x equals, okay, nothing can simplify, so this is going to be negative 2 over 9x. So I got negative 2 over 9x. I have negative 1/3 times negative 4. I'll do this here on the side as well. Negative 1/3 times negative 4 over 1. And be careful, watch your signs. A negative times a negative now becomes a positive, and this just becomes positive 4/3. So I'm going to add, so plus 4 over 3 equals, and this side stays the same, 1/2 a minus 7. Alright, so now let's look at our denominators now. We have 9, 3, 2, and the 7 doesn't have anything, so we have an imaginary 1. Alright, so find your biggest denominator. My biggest denominator here is 9. So let's just look at the multiples of 9. 9 times 1, 9 times 2 is 18, 9 times 3, 27, and so on. So now you want to ask yourself, can all these numbers divide into 9 evenly? Well, 9 can divide into 9, 3 can divide into 9, but 2 cannot divide into 9 evenly. So I cannot do 9 divided by 2 and get a whole number, so that's no good. How about 18? Can I divide each one of these? Can I divide each one of these numbers into 18 and get an even an integer? So yeah, 18 divided by 9, yes. 18 divided by 3, yes. 18 divided by 2, yes. 18 divided by 1, perfect. So I'm going to multiply everything through here by 18. That would be my common denominator. Alright, so again I'm going to do, what I could do here is, depending on the technique that you prefer, you can multiply them all 18 over 1 here. You can do it all on the side, or you can put the 18 over 1 next to all of them, whatever you like. Okay, so I would take advantage of that. I'm going to do it here mentally without the side work or without the 18 over 1 next to all of them. But again, whether you like this method here where you wrote down 6 over 1 next to all of them, or if you prefer writing this down on the side, take the extra 30 seconds, 45 seconds, whatever it is, and get the right answer on your exam or your homework. Alright, so I see here 18 divided by 9, so what I'm doing, this is what I'm doing mentally. 18 divided by 9 is 2, so then I have 2 times negative 2 is negative 4x. Alright, then my next one is I'm doing 18 divided by 3 is 6, 6 times positive 4 is positive 24, equals. And then again I'm going to do 18 divided by negative 2, 18 divided by 2 is 9, 9 times a is 9a. I have two different variables here, we'll fix that in a second. And then I have 18 divided by 1 is 18, and then I have 18 times negative 7 is going to be negative 70, and 56 is going to be 126. Alright, so little mistake here. This should be the same variable, so let's call this a instead of x, so that we have all the same variables here. So I got negative 4a plus 24 equals 9a minus 126. Alright, so again I'm going to try to bring my a's over to one side and my constants over to the other side. And again I'm going to do this in one step. So I'm going to say plus 4a plus 4a. Okay, that will get rid of my 4a's. And then I'm going to do plus 126 plus 126. That'll get rid of my 126's. Excuse me on my alarm. Alright, so those go away, so I have 150, 24 plus 126 equals, I got 9a plus 4a, which is 13a, and then 126 simplifies. Alright, and we're getting closer. I'm going to divide both sides by 13. 13 over 13 simplifies, so I have a equals 150 over 13. Again, always try to simplify it. You could leave it an improper at this level. 13 does not go into 150 evenly, so just leave it just like that. Alright, we have a couple more examples. Alright, so we got 1 1/2 x plus 2 equals 2 1/3 times quantity 1 1/3 x minus 4. Alright, so I made this one a little bit more difficult. We have a mixed number here, and we have single distribution. What I want to do first is concentrate on these mixed numbers here. Okay, we know we're going to be multiplying something, so when we're multiplying fractions, everything should be as an improper fraction. So let's take care of that first. Let's make everything improper. So 1 1/2 x is going to be 3/2 x plus 2 equals, alright, and again this is just going to be 1 1/2. Again, I'm multiplying 1 times 2, adding 1. 1 times 2 is 2, plus 1 is 3. 3 over 2, just a quick refresher. And here we have 2 1/3. 6 plus 1 is 7 over 3 times the quantity 1 times 3 is 3 plus 1 is 4. 4 over 3x minus 4. Alright, so the only thing I did was just convert these into improper fractions. Now I'm right back to this last problem I had before. Okay, so nothing has to happen here on the left side. So 3 halves x plus 2 equals, notice I'm always writing down my steps. It's so much easier to go back and follow yourself and follow your steps to see if you got the right answers. Alright, now I'm going to distribute here. Okay, so I got 7/3 times 4 over 3x. Nothing simplifies here, so I just have 7 times 4 is 28. 28 over 9x equals 28 over 9x. And then I'm going to have here 7/3 times negative 4 over 1. And here again I have negative 28 over 3. Nothing simplifies, so minus 28 over 3. Alright, so we have our, I'm going to put the 2 over 1 here. Again, we're working with the same examples last example. 9 is my greatest denominator, concentrating on denominators. Multiples of 9, 9, 18, 27, so on. 2 does not go into 9, so we can't use 9. 2 goes into 18, 1 goes into 18, 9 goes into 18, and 3 go into 18. So we're going to use 18 as my least common denominator. So we're going to multiply everything through by 18. Again, whatever method you choose, if you want to multiply every term by 18 over 1, or if you want to do it here on the side and multiply them separately, great ideas, do whatever you like. Okay, I'm going to take the shorter route. I'm going to say, okay, 18 divided by 2 is 9, 9 times 3 is 27x. 18 divided by 1 is still 18, 18 times 2 we're going to say is 36, so plus 36 equals, we got 18 divided by 9, which is 2. 2 times 28 is 56x. And then we have 18 divided by 3 is 6. And we have 6 times negative 28. Be careful, okay? 6 times negative 28. So it's going to be negative. And 6 times negative 28 is 120. And 48 is 168. Alright, so watch your signs here. Okay, I'm going to combine like terms. I'm going to bring my 27x over to the right. I'm going to bring my negative 168 over to the left. So I'm going to do, okay, so let's do this together. Minus 27x, minus 27x. And this one I'm going to add 168. And I'm going to add 168 to both sides. Alright. 27x and negative 27x, see you later. Here we have 14, 1, carry the 1, we have 10, so we have 204 equals 56 minus 27x, so we have 4, 1, so we have 29x, and that goes away. Alright, and now our last step here is just divide everything by 29, and we have x equals 204 divided by or over 29. I don't believe that simplifies. That'll be your final answer as well. Always check to see if these simplify. I kind of just made these problems up off the top of my head, so they didn't work out so nicely, but I would say for textbooks and test purposes, more than likely your teacher would put something on there that would simplify easier. Alright, and I got 2 more examples for you. Alright, so these are still rational numbers except in the decimal form. So we got 0 and 3/10x plus 5 and 2/10x equals 0 and 4/10x minus 8 and 4/10x. Alright, so you could easily work with decimals if you like. What I'm going to do is show you a technique of how to get rid of decimals. Okay, if I took this decimal and moved it over one place to the right, I would have a whole number here. If I took this decimal and moved over one place to the right, I would have a whole number here. And if I did that to all of them, all these would give me one whole number if I just move these over one time to the right. Alright, so taking anything and moving your decimal over to the right by one spot is the same as multiplying by 10. And we have 1, 0, and 10, so we moved it over to the right once. If I were to multiply by 100, I'd be moving my decimal over 1, 2 times to the right. This is a 1 time to the right. This will be 2 times to the right. If I multiply by 1,000, I'd be moving my decimal 3 times to the right. So in this case, I want to multiply by 10, so I can move all my decimals over 1 time to the right. So this becomes 3x plus 52 equals 4x minus 84. All right. I want to get my variables on one side, constants on the other, so I'm going to bring this over that way. I'm going to bring this one over that way. So I'm going to do minus 3x, and here I'm going to do plus 84, and solve this. So my x's go away here, so I have 6, 13, 136 equals 4x minus 3x, it's just x, and that goes away, so my final answer is x equals 136. Okay, one last example. Alright, so we got rational numbers with decimals again, and this time we have a double distribution here. Okay, so before we multiply by 10, you can distribute twice and then multiply. This one you actually have two different means of doing this. I'm going to show you two different ways to do the same problem. Okay, so let's highlight this one, and I'll show you two different ways to do this one. Alright, and we'll set up another screen. So option number one, okay? Option one, we can distribute in, and we can get 1 and 2/10 x minus 3 and 6/10 equals 2 and 3/10 times 5. We get 11 and a half minus 44 and 6/10 x. Alright, and then we're going to combine like terms. I'm going to bring my negative 4x over that way, and I'm going to bring my negative 3.6 or 3/6 over this way. Alright, so I'm going to add 4 and 6/10 x, add 4 and 6/10 x, and then I'm going to add 3 and 6/10, add 3 and 6/10. Alright, so we're adding, make sure we line up our decimals here, and let's go with the green. Alright, so if we add these up, we get 5 and 8/10 x equals, that goes away, we get 11 and 1, carry the 1, 3, 4, 5, 15 and 1/10. This goes away, and then our last step here is just to divide by 5 and 8/10, divide by 5 and 8/10, so we got x equals 15 and 1/10 divided by 5 and 8/10. Usually don't want any decimals in the denominator, so here you could just say this is going to be equal to 151 over 58, just moving my decimals over once, unless your teacher wants you to divide and round, or whatever the instructions are at that point. If you were to divide 15 1/10 over 5 and 8/10, if you round it to the nearest whole number, or round it to the nearest tenth, you would get an answer for approximately 2.6, and you could easily do this on your calculator. Alright, or our second option here. Okay, so we did this all with the decimals. Sorry. Okay, so we could again distribute through, and then we can remove our decimals. I'm going to show you a little strategy here. Okay, since we have a number, our coefficient in front of our quantities here, my goal here, and everything inside my quantities, if you notice, inside the quantities, these are all integers. Okay, there's no decimals inside my quantities here. They are all integers already. So what I want to do is I want to turn these two numbers into integers as well. Okay, so all I have to do is move this decimal over once and move this decimal over once. So they're both, in both cases, I need to multiply by 10. So what I'm going to do is multiply this whole thing by 10. Whenever these two numbers are attached like this, okay, I'm only multiplying the first term by 10. I'm not multiplying what's in here by the 10, okay, because these are attached to a multiplication. Okay, it's like saying if you had, and this is comparable to saying like 3 times 2 times 5. Okay, if I would do this is 3 times 2 is 6, 6 times 5 is 30. I would not do 3 times 2 and say 6, and then do 6 times 5 and say 30, and then say, okay, well, this is 36. Okay, I would not do this. This is one I would not do. Right? I would just do 3 times 2 left to right, get an answer of 6, and then multiply by 5. So which is why I'm going to only multiply the 1.2 by 10. So this is the same thing as saying 12 times x, the quantity x minus 3, equals 23 times the quantity 5 minus 2x. Alright, and then this, now we could go about and solve this one. So we have 12 times x, 12x, minus 12 times negative 3 is negative 36, equals 23 times 5 is 115, minus 23 times negative 2x is negative 46x. Okay, and again, we're going to solve this. We're going to add 46 to both sides, bring in my x terms on one side. Alright, so we got 58x minus 36 equals 115. Alright, so I took my time on this one. I actually did it step by step, but again, you could do whatever you like. Normally I would do 2 steps at once, but we'll go with this one at this point. So now we got adding 36 to both sides here, so now I have 58x equals, and we should have 115 and 36, we'll have 151, carrying the 1 here. Alright, and then my last step here would be to divide by 58, and we got x equals 151 over 58 as a fraction. And that should be comparable to the last answer we had here as well. Yep, 151 over 58. Alright, so you have a couple options on how to solve these problems. Definitely, if you feel like you have another way, try it. Try it. Ask your teacher. There's no right or wrong way to do a math problem. As long as at the last answer, you're on the same page. Alright, good luck.